You know, in the world of technology, there's this invisible force, kind of like a digital version of physics, that's quietly deciding everything. Where we build data centers, how our apps get designed, even why your favorite streaming service works the way it does. It's reshaping our entire digital landscape, and today, we're going to pull back the curtain on it.
To get our heads around this, let me just ask you a simple question. Why is it so much easier to build a factory right next to a mountain of iron ore, instead of trying to move that entire mountain to your factory? The answer feels pretty obvious, right? You bring the small, mobile thing, the factory, to the huge, unmovable thing, the mountain.
Well, here's the thing. In our digital world, massive amounts of data act exactly like that mountain. And I want to be clear, this isn't just some clever metaphor. It's a real, fundamental principle that governs modern tech, a force with very real consequences for cost, for speed, and for innovation.
And that brings us to the big idea, the one truth that shapes almost every major architectural decision being made today. Data has gravity. Seriously. Just like a planet's gravity pulls things toward it, huge collections of data pull applications and services into their orbit. The bigger the data, the stronger that pull.
So, let's actually give this invisible force a name. Let's name the villain that tech architects are constantly wrestling with, the very thing that sets the rules of the game they have to play.
And here it is, data gravity. It's the phenomenon where large data sets just naturally attract applications, services, and all that computational power right to wherever that data lives. The bigger the data set, the stronger its pull. It basically becomes the center of its own little universe, and everything else is forced to revolve around it.
So, what creates this gravity? Well, it's not just one thing. It's a whole mix of powerful factors. First off, data just piles up over time. It gets bigger and bigger. Then, it's incredibly expensive to move data out of a cloud provider. You've also got the physical limits of bandwidth and speed, and on top of all that, sometimes for legal or compliance reasons, data literally isn't allowed to move. You put all that together, and you get this immense gravitational pull.
And this brings us to the harsh reality of why trying to fight data gravity is, more often than not, a losing battle. It's not about not trying hard enough. It's about slamming up against three very real, very stubborn walls: cost, speed, and the unbreakable laws of physics.
And this chart just lays it out perfectly. Look at this imbalance. On one side, you have data. It's heavy, it's persistent, it sticks around. On the other side, you have compute, your apps and services. That stuff is light and ephemeral. You can spin it up or down in a flash. Moving petabytes of data is crazy expensive and can take hours, even days. But moving a computer program, that's cheap and takes seconds. The choice becomes a no-brainer.
Let's put a real number on expensive so you can feel it. A typical cloud provider might charge you something like 12 cents for every single gigabyte of data you move out of their system. It's called an egress fee. Sounds tiny, right? But what if you have a petabyte of data? Well, that's 1,000,000 gigabytes. All of a sudden you're looking at a bill for over $100,000 just to move your own stuff. Ouch.
And here's the kicker. Even if you could afford it, you can't beat physics. The speed of light traveling through a fiber optic cable is not instant. For every 1,000 kilometers your data has to travel, you're adding about 5 milliseconds of delay or latency. That might not sound like a lot, but for things like self-driving cars or real-time online gaming, 5 milliseconds is an absolute eternity.
So if we can't move the mountain, what do? We have to change our entire way of thinking. This is the big pivot point, the moment where we flip the whole traditional model on its head and find a new way forward. And here's the solution. It's so simple, it's beautiful. Instead of trying to move the data to the compute, modern architectures are increasingly moving the compute to the data. Don't move the mountain, build the factory right next to it. This single idea is the revolutionary principle that finally lets us work with data gravity, not against it.
You can actually see this evolution playing out over the last decade. We started with centralized compute, where everything ran in one big data center. Then, we got smarter and moved to distributed compute, spreading our apps across a few regions to be closer to our users. And now we're at the final logical step, edge compute, where we put the processing power right beside the source of the data itself.
And that brings us to the hero of our story, the technology that is the most direct, the most powerful response to the challenge of data gravity. It's called computing on the edge, and believe me, it is changing everything.
So what is it, really? Well, in the old model, data from, say, a smart car or a factory floor had to make this long, slow trip all the way to a central cloud server and then all the way back. With edge computing, we put the compute, the brain power, right there next to where the data is being born. We're not just closing the distance, we're basically eliminating it.
And this is not some abstract theory. This is the tech that's making our future possible. Autonomous vehicles absolutely cannot wait for data to travel to the cloud and back to decide whether to hit the brakes. Industrial robots need responses in sub-milliseconds. Real-time gaming, augmented reality, none of this stuff works without processing data at the edge, defeating that latency that data gravity tries to impose.
So what does all this mean for the future? It means we are fundamentally moving into a data-centric world, a world where the location of the data is the single most important factor, and everything else, our apps, our infrastructure, our business logic, has to be designed around it.
And we're already seeing the next wave of amazing innovation being built on this very idea. Take federated machine learning, for example. Instead of pulling all your personal data from your phone into the cloud to train some AI, the AI model is actually sent to your phone to learn locally. The model gets smarter, but your sensitive data never leaves your device. It's a complete reversal of how we used to think.
So the real takeaway here is this. Data gravity isn't a problem to be solved. It's a law of nature, something to be understood and designed for. The old way of thinking of bringing everything to one central brain is over. The future is about distributing intelligence out to where the data lives, which leaves us with a final, fascinating question to chew on. As data truly becomes the center of our digital universe, what new and unimaginable technologies will we see begin to orbit it next?